Good afternoon, everyone. My name is Lynn Barrett, and I am a director with the Dallas Office of Improving, and I'm excited to welcome today Scott Poulin, Vice President of Technology at Improving, to lead this session on rethinking architectural strategies for complex knowledge work. He's actually a full stack engineer at heart with a deep focus on back-end systems. Scott brings a rare blend of technical expertise and real world experience across industries like transportation, finance, healthcare, and nonprofit. With degrees in physics, business, and information systems. What do you do in your spare time, Scott? From the University of Nebraska at Omaha, go Mavericks, and the lifelong leadership value of an Eagle Scout. Scott is passionate about using AI and machine learning to drive meaningful, scalable impact. So in today's talk, he'll introduce a framework for designing intelligent systems that leverage semantic discovery layers, adaptive compression, and density-aware patterns, all inspired by principles of distributed AI. So we're glad you're here for this unique perspective on building ecosystems that truly amplify knowledge work. And Scott, with that, I'll turn it over to you.
Perfect. Thanks, Len. All right. Thanks, everyone, for coming. We'll jump right into it just because there's a lot of content. So we're going to skip that because that was just me, and Len did a great job introducing me. So real quick, I want to talk about the overview of the two different aspects that we're going to run through. So I can't talk about our framework when it comes to machine learning and AI lifecycle and how that looks when completing complex problems with first talking about AI adoption and what that means and how that plays into the other framework. But first and foremost, so the AI adoption framework, what is it? Honestly, it's just about the aspects of where do I live in as my enterprise in the aspects of introducing AI to all realms of my business. And then what does that feel like? Are we in the sense of introducing AI and machine learning technologies, kind of just ad hoc, where you have kind of a individual that's championing it and doing it within inside of their own realm and their own personal time, and then moving kind of in from outside of the ad hoc to experimental aspects where you're looking and introducing it into other areas, and then you're moving into a strategic area where this is more in the aspects of we have lines of business that is actively using machine learning and artificial intelligence. And this is kind of the sweet spot when it comes to the AI adoption framework. This is the place where you really want to live as it stands today. And then if you really want to jump into it and change the industry and how AI is and what that looks like, you move into the transformational realm. And this is you have all kinds of different platforms set up and you are innovating and creating new things with inside of the AI industry and less about your business industry. So that's why I say the strategic part is honestly the very sweet spot for most companies. Unless you are a technological driven company who really wants to innovate in the AI and machine learning space, you don't really move into the transformational spot unless you want to go down that path. But that being said, these three areas are very key to understanding the next part, which is the machine learning and artificial intelligence lifecycle framework that we have effectively built up to help solve these complex problems and introduce AI to help solve them. The biggest thing here is that once you move into a strategic kind of zone or like maturity level, there are things that come with that. And there are requirements that say that if you have done X, Y, and Z, you are at that strategic level. One of them being having a machine learning and AI platform that is empowered by a data platform. Those two things that work together are really key to be really strategic with how you deploy and manage machine learning and artificial intelligence solutions. That being said, it is not necessarily required to get your feet wet and start going into that experimental stage and start releasing machine learning and AI solutions. So it's just a forward progression of how you evolve through aspects of AI adoption. So that being said, we'll jump into the aspects of machine learning and AI lifecycle. What is it in a sense? It just allows us to scale and build machine learning and AI solutions and projects without effectively introducing technical debt to start off with. Way back when everybody didn't even know about the hype of AI and machine learning, there was a lot of tech that was built by companies that were on the bleeding edge of this type of implementation. And this is where this framework comes from, is the sense of avoiding the aspects of tech debt, technical debt to effectively make sure that your solutions are implemented properly to effectively actually drive value out of them. One of the biggest statistics that they saw early on with machine learning and AI projects is that over 50% of them would fail due to the aspect of not having a structured framework to follow. And so that's where this kind of originates from, is with a collaboration of Google and Meta. This is where this framework effectively comes from. And so from here, we are able to use this to actually build into solving very complex problems. And we'll go through a bunch of different scenarios and conversations about this. But the biggest thing here is that the first five pieces of this framework are the most critical to effectively solve your complex problems and to introduce AI into them and do that most effectively. So, jumping into that, we'll go into what is called problem definition and selection. So, without understanding your problem that you're trying to solve, you can't necessarily solve that problem, right? So you have to have a really good understanding of what that means. And so what we typically like to do is do a machine learning feasibility study, machine learning or AI feasibility study, using simple heuristics to effectively understand, does it make sense to go down this? And effectively, in layman terms, it's a gut check. Does this make sense for us to go down and start doing this for this particular problem? Additionally, with that is making sure that it's metric driven, having a good understanding of what that what you're trying to effectively track is kind of one of the most critical ways to identify ROI within inside of your project. So if you don't have a way to say from a business standpoint, are we doing something effectively, you kind of lose that ability to say what we released is actually valid or actually helping the customer base that we want to use. And then that traceability, this falls into that traceability assessment to understand, hey, do we have data available? What does the data complexity look like, and how do we have to manipulate the data to make sure that we get the predictions that we're looking for, which leads into helping us understand that expected ROI. And then from another realm and other perspective is evaluating your risks. So it's a big, I would say, three-pronged kind of approach. It's your possibility and the capability of actually doing it, and is it potentially capable? And then do we have the ability to trace and understand what we are building? And then looking at it from a risk mitigation standpoint. Risk in the sense of bias, are we going to, if you're building a solution that is customer facing, one of the big things there is you have to make sure that you account for all individuals that are typically interacting with your system. So that's one realm to look at it. System capabilities do based off of, and this comes from like the Google and Meta scale. Not a lot of companies have to face this if they have a customer facing solution, is the aspects of, do we have the hardware solutioning or architecture to support 1 million requests at a given second? So a lot of times you can take this and scale this back. Most companies are probably only looking at anywhere from 100 to maybe 10,000 a second, but it's still important to consider from the service that you're going to provide if it is externally facing to your company. And then ecosystem, understanding whatever we're building, is it going to societally impact at a negative perspective? So that is one of those things that there's a lot of different examples here, but we won't jump into it. But it's just one of those things that you have to consider, is what we're building actually going to help our end users or our company get to the level that we want to be strategically. And then lastly is the value validation. Just making sure there's a bunch of different little trade-offs that can effectively happen here. It is understanding what we're trying to build align with our business and strategic goals, and then how helpful is it in the sense of impacting our customers or the end user at the end of the day. So that's kind of that sweet spot of high alignment and high helpfulness. That's a good, like, easy way, gut check it again, to say it looks like that's a good potential worth it to go down and understand. So this is just kind of the very start of when you are looking at a complex problem. These are all things you do first. And if you ever run into a scenario where some of this is kind of up in the air or up to question, It's an indicator whether or not, okay, maybe we should wait on solving this complex problem and look at a different one, which drives us into the metric definition and success criteria. So the most important part of this, I would say, is most likely the first two, just because without these first two defined, it's very difficult for you to successfully implement a very complex AI project. Direct versus proxy metrics, what that effectively means is direct is from a business perspective. How much money did you make with implementing this technical architecture or this machine learning implementation? And from a proxy standpoint, it's like, how accurate was my model in doing X, Y, and Z? So those are just kind of examples when it comes to direct versus proxy. It's good to have both, but if you don't have one or the other, it becomes exponentially more difficult to manage. Accuracy and all that stuff from the model perspective is kind of easy to implement because a lot of that stuff comes out of the box with stuff and software that you implement on top of this. But the hard one is the direct. A lot of times you'll say, like, this is the business metric that we want to hit, but it's very difficult to measure that based off of data that you have. So you either have to go back and collect the data, which we'll talk about here in a little bit, or you have to effectively reframe your problem, and we'll talk about that here in the next slide as well, is making sure whatever you build as your metric is actually something that you can track and it's measurable and understand. The second part is counterfactual analysis. And what this means is, can we do this without machine learning? And can we not do with this? And then when you do it with machine learning, what are the benefits and possibilities that come out of that? When doing without it, a lot of times it's very manual, very intensive, but it gives you a baseline to understand, hey, this is what we should expect from an implementation. And then once you implement with machine learning, understand, or AI, understand the aspects of, okay, what are the gaps between those two, and how can we make sure that they align accordingly? And so this is just one of those other pieces, is if you get better results from just doing it without machine learning or AI, it's probably a good reason to not do it. But if you get additional speed or enhancement from the aspects of doing it with machine learning and AI, it may still be a good contender as to why you should. Outside of that, multidimensional testing, this just allows for you to understand the aspects of whatever you implement. Is it covering your basis of understanding of, are we missing any areas when we were introduced to new data that we may not have? What is the impact and how do we address those problems? That it just helps with understanding a full perspective of how you're going to implement this, because when it comes to complex solutions, this is probably very like one of the most like intense things that you have to do, because in the case where your complex problem you don't have all the data for that complex problem to be solved, but you still have to build a solution on top of it because it succeeds in meeting all the other criteria of why it's a good problem to solve. You should have to understand those edge cases and be able to build around it and say, when this edge case happens, this is what we're going to do. And so this what drives that initial engagement of, okay, we start small and then grow. So we'll get into that other aspect as well down the line, but this is one of the other major pieces when it comes to solving complex problems and trying to put AI inside of them. So additionally, fairness, alignment, this is stuff we kind of discussed a little bit already with problem definition, but it's just additional aspects and like understanding, making sure that your metrics account for that as well. There's a bunch of various different types of tools to help check this and validate your model just early on without having to deploy it, which is kind of nice because now you can check it without having to go through all the manual effort of deploying and gathering data and all that stuff. So it just gives you another gut check to say, okay, this is a good option to move forward with. And then lastly, I would say working with your domain experts. If you don't have one, it's going to be very difficult to implement that complex problem. Most solutions inside of the realm of solving complex problems have some sort of domain expert that understands that problem to a certain level of degree. And so working with them to understand all the puzzle pieces that occur with inside of there and what you're going to have to effectively solve is very key. And you can use other easy deployed tools to effectively help explain why a model did X, Y, and Z. And you can talk with the data domain experts to help them understand why it did A, B, C, and they'll be able to most likely work with you to say, hey, oh, you're missing this data, or you need to do X, A, B, C, D. So there's a bunch of different things that inside of here. A good example of this is like when we use, I think it was most recently that somewhere in the Middle East, they just released an AI doctor. And so part of that, I would say here in the States, if we had a system that's similar, we'd most likely pair it with doctors and say that a doctor would review whatever the AI predicted when it came to some sort of disease to help it understand, uh, help the doctor understand why the AI made a decision. And so there's a bunch of different tools that you could put on top of your prediction models and AI models to effectively help show like, hey, this is the reason why I did A, B, C. And the doctor can either trust that result or say, no, that's not correct. It's missing this. And then provide feedback to allow the AI to get smarter into the future. So that being said, we'll jump to problem reframing. So I kind of touched on this a little bit earlier. And what this is and why it's important is that there are some complex problems that it is very difficult to measure, have a measurable metric effectively. And so a lot of times you have to reframe your problem in certain ways. And a kind of big example to this, and most commonly, is the aspect of I want the success of a product to increase by 10%. How do you really measure the success of a product? And so you have to reframe that. And a lot of times people will reframe it and say, okay, total purchases in the store is kind of a good indicator to say, hey, it seems like it's successful. But there's a bunch of other little things that can go into that. But that's just an example as to looking at a problem and say, this is not a measurable achievable goal in the sense that we can put computer logic around it to say like, hey, this is actually valid versus total purchases is something that we can track. There's transactional events that happen. We get that information back. We can put it on a dashboard and say, hey, total purchases is going up, which allows us to make the effective determination to say the success of the product is occurring. That's just one of the big things here is that when you run into complex problems is making sure that whoever you're working with who establishes the goal for that problem is not producing a measurable metric, reframe the problem so you can have it be measurable and work with the subject matter expert or the domain expert and say, hey, I can't measure that. That's not something that we can easily measure. Here are some other potential metrics that we can measure. Does it make sense to do A, B, and C together to give you that motion? And a lot of times there's a little bit of back and forth with that. And so that's kind of the model that helps you establish that going forward into the future. So that being said, you can always get to the point of where you have multiple metrics that meet that goal, but you need something called modular decomposition, which effectively breaks down components, machine learning and AI components into modular pieces that you can swap in and out to do various things. And by combining them together allows you to achieve that measurable metric. Additionally, with inside of there, which helps kind of get the understanding of like moving towards this problem reframing and helping drive understanding around the problem itself is feature standardization. So there's something called a feature store, which just allows you to store information about things that you're trying to predict and their related features, quote unquote, or entities of data that helps you understand what you're trying to predict. And so having that in a kind of singular place really helps drive that speed of interaction to effectively have a solution coming out the door on the other end a lot more quickly, which leads into the simulated prototyping, helps you build up mock-ups and understand from the sense of whatever I'm building, does it make sense? Are we learning? Are we effectively determining our kind of theories around a particular solution? Is it solving them and doing X, Y, and Z? On the large language model side, there's a bunch of pieces as well from being able to frame problems in the aspects of response quality and all that stuff. So that's another one of those metrics that you have. Additionally, it's also very good to document alternative approaches in a problem formulation matrix. Effectively, this is just a way for you to write down in a simple chart to compare all the different approaches that you've already taken, say what is the best one? Can we have a mix of both? Do ABC? Is there a way to put rules inside of there and then utilize AI? So it really helps build out kind of like a pros and cons of there are various approaches that you're going to take when doing problem reframing. Data collection, this is, people don't realize, but data collection in the world of machine learning and AI is probably over 80% of most projects, just simply due to the fact that clean data is very difficult to achieve. And so it's very important that you go and start building and constructing data sources or have a data platform per se that allows you to separate analytical information into various stores. Kind of structured data lives in that realm, and then object storage for unstructured data. So unstructured data is typically like images or documents or videos, while databases and rows of columns or like things like a CSV or a spreadsheet kind of lives in a structured format that lives typically with inside of some sort of high-speed database to integrate with other pipelines for both pipeline automation and then also ETL transformations, and then for like things like lineage tracking, and then also in the sense of providing data to streams in real time and all that. So additionally, privacy enforcement is very key in these platforms. So making sure that people who have the right to access certain data is critical. So this is more from the perspective of an enterprise, making sure that this is put in place, making sure that you have like either ways to tokenize information so not everybody has access to like specific PII or PHI or anything like that. So it's just important things to keep in mind. And then from the quality insurance side of things, because there is this age-old term now, I guess it's age-old just because it's been said forever, is garbage in, garbage out, in the sense that if your data is terrible, you're going to get terrible results. And so that's where data quality profiling tools and data distribution monitoring systems also really help to help you understand the aspects of based on my data that I'm using to predict a particular functionality, is the relationship between those two changing? And if it is, it's time to start looking at a different data set to build and make that prediction. So there's a lot of pieces inside of there, but that's kind of the general sense of one of the big things about data collection and preparation is making sure that your data is good and it actually doesn't change from what you're trying to predict. Most cases, they're going to change, but there are ways to help prevent that and at least get notification when it does, so that way you can start working to build a new data set. So lastly, not lastly, but in the sense of solving complex AI problems efficiently and quickly, this is probably the other major piece. You want to start small. So after all of this other information you've collected your data, start small. It's okay that if your model doesn't first predict the initial like metric that you design and put out, if there's a sub metric that kind of correlates to it, or if you add another metric to it, gets to that point, if you're just calculating that first one, that's always a good first start, because a lot of times it's a lot easier to build this sub metric than it is to build the higher level metric. And so, especially in complex problems. So it's okay to start small and then work your way up. Because if you are in the maturity level where you have built a platform to help enable you to do really fast prototyping, really fast iteration experimentation, you can effectively build new solutions on top of what you originally built and get to that final solution a lot quicker. And so there's a bunch of different ways to go about this, just like gut checking type feeling as well. Again, using AutoML if you have a lot of structured data, using AutoML just to kind of get heuristics and information out of that model to understand, are we going down the right path? And so that's one of the biggest things that you can do here. Failure is expected at this point. You may have made a wrong assumption based off of your data construction or about the problem in general. And it is expected that you will run into the sense of failure as what we were trying to predict isn't actually predictable based off of a data set or based off of the information we currently have. And so that's okay. The nice part about that is why that's okay is if you're doing fast iteration and experimentation, you can get past that. Okay, we've learned from this where this part of it isn't valid. Let's swap it out for something else. And having a nice machine learning platform allows you to do that very fast, almost inside of the same day. You could probably test over 100 different models and different ways with testing that model as well. So just a lot of different things that kind of go into this. But the biggest thing here is making sure you have a machine learning platform that enables you to do this really fast experimentation, because this is the only way that you'll be able to solve a complex problem in a reasonable amount of time to achieve your expected ROI for solving that problem.
Hey Scott, we've got a question
Yeah,
from our
definitely.
audience. What are the biggest challenges in changing how the organization collects data?
Yeah. To be honest, it's a lot of it is around data quality and like building that system that is centralizing that data to make it available for analytics and machine learning. Right now, I'd say that one of the biggest things that we see with a lot of different clients is that they're trying to move a centralized store for this purpose to enable machine learning and AI purposes. But a lot of that data is siloed. And then now we have to go find SMEs to understand that data, to get it integrated in and understand it. That's why I say that the number one problem with machine learning and AI is data collection and preparation. You will spend a lot of time here because if you want to do it fast and at scale for complex problems, you need a data platform that is going to enable you to do things very efficiently. And so one of the biggest things that we see with a lot of clients is that they try to do this type of project where it's complex, really hard, and they don't have that centralized store of information and data, and they constantly try to find ways around the aspects of not having that data, and they will constantly fail. And so this is just one of those things of where you start to go down alleyways of individuals coming in with PhDs. No offense to PhDs. I think that they're totally valid, but a lot of times they'll bring PhDs in to say like, hey, redesign and build something that will help us do this because we don't have the data. When in reality, the time should be taken to understand what data do we need and getting that data and putting it in a platform that's easy to use. So that is one of the biggest things that we see with a lot of different clients is that they will try to solve the problem without the data. And so that's the biggest thing that I would say that if you don't have the data, it's probably not a good complex problem to solve. Hopefully I answered that question well.
Great. Yeah, great job. I know we've talked about AI assumptions before that AI will fix my data. So
Yeah, yeah.
appreciate that answer.
That's
Yeah.
that's also another dangerous thought as well. Utilizing data or AI, especially like generative models, on top of data is it can be dangerous if you're not careful with it. Especially if you expect deterministic answers from a probabilistic machine. So that's one of the biggest things out there is be very careful when utilizing AI to generate data in a way that you expect deterministic answers, meaning that it is a structured answer that should be the same every single time with a probabilistic system that will give you various different answers regardless of how you call it in the same exact way. So it's just one of the big things to be careful of in this space. So, but yeah. So the next five modules are going to go very quick because they are, I don't want to say less important, but it's the easier side when solving complex problems. A lot of it has to go with the first five and determining all of that information. That helps set in motion to make everything easier for you. Now, if you have not done all five of those first parts and you have not done your due diligence in that space and you have set yourself up for success, the next series of five is significantly more difficult because you will be confused as to why aren't we getting the results we expect. Because the next series of five is just maintaining and supporting and allowing you to scale and grow that system to make sure that it actually solves the problems you're looking for. And so, especially the complex ones. So, that being said, the first five of what I just discussed, very critical, especially when solving complex problems. If you do not do that first, it becomes terribly difficult to go down the next series of five tasks as well. That being said, model selection and development. So after you've done all these fast iteration, it's kind of determining, okay, based off the metrics that we have and understand, go through and compare all the different models, the positives, the negatives, the potential impacts, the risks, understanding the risks that you established earlier. How does this look like in here and understanding, okay, what is the best optimal model? And so you can kind of search through there and allow you to select it, and allows you to also understand from a resource perspective, when we put this model in production, what kind of expectations do we have on it? How fast can it scale? How fast can we get the data to it to make accurate predictions? There's a bunch of different architectural considerations inside of this, especially when you determine a model that requires data in real time or requires data in a batch basis, or there is a window of time where one set of data comes before the other. There's a lot of different considerations when it comes to model selection and development and deploying it outside of here. So keeping all of that in mind, you determine all that information in the small scale solution iterations. And then you get to this point where you're like, okay, based off of everything that we've already collected, we know we need to go X, Y, and Z and go deploy to here. And so that's just what kind of helps you and do a lot of the governance stuff and doing all that. Additionally, there's some other small things that I would recommend doing to help with this, especially as you move into the future and you have a repository of models and both an AI and machine learning, is having a model card for those solutions or an AI card effectively. They can kind of be interchanged. But effectively, what this does is it tells you this is what it's been trained on, this is what it does, these are its inputs, these are outputs, this is what we expect from it, and then this is how fast it can perform based off of all of these various conditions. Having that information that you can quickly reference allows you to build more efficient solutions as you can plug and play and move things together and build larger pipelines for AI or machine learning solutions. That being said, evaluation and validation. One of the big things here is I see this kind of pretty often is that the lack of unit testing of your actual functional code. And a lot of times it's very difficult for people to understand as to, well, how do I unit test a machine learning system that can be probabilistic? And the biggest things is you can say that I expect that my model won't do ABC or won't return nulls and won't do it won't be over this amount based off of what you understand about the probability predictions or ABCD. So it just puts these controls around it to just gut check yourself and make sure that what you're doing is valid. Additionally, there's a bunch of machine learning things that you can do to test your models and all that side of things. But from the AI layer, it's just putting barriers around it to make sure that, hey, based off of these various different types of data inputs, what is the probability of something coming out and being something that we don't expect? And making sure that you put tests around that and understand that. And so you can scale that from the unit test perspective. And then integration tests, it's like, okay, if I have other functionalities integrating in various APIs and data pipelines and data flows, how does that all come in and how do we make sure that we test for that and what happens when that fails? What is the expectation? One of the big things for integration testing, it's a very common term, but it's common both in machine learning and artificial intelligence. It's training serving skew. Effectively, the data that I trained on during building the machine learning or AI solution is not readily available at the time that I need to make a prediction. And so when this happens, this is due to the result of a failed pipeline, or like in the sense of like utilizing Kafka, there's a topic that gets blocked or does something that doesn't allow me to retrieve that data that I need at that given time, resulting into a bad prediction. So what you will need to do is make sure that in the event that happens, that your AI or machine learning system knows, so that if it receives a request, it can default to a safe answer. And I say safe answer because if your system is externally facing, you will run into potential litigation issues if it predicts something that is not good. And so you just have to be very careful with that. And with large language models, they have their own set of integration tests and stress tests and things that you can put around it called guardrails. So there's a lot of different things on that side of things as well. But I like to include that and clump that into the integration test aspects to help make sure whatever you're trying to predict or output is what you expect it to be. And then a result of something happening, how do you handle that? So that's where this all kind of comes in. And then bias mitigation, one of the big things here, and we kind of mentioned it very early on, is just understanding based off of the model that we have now selected, is it biased in a shape, form, manner? And this is mostly important if you have a solution that is externally facing and has to deal with human demographics and understanding that. So making sure that whatever you put out in the world is actually fair based off of whatever it's predicting. One of the most common horror stories in this spot is the aspects of loan approvals. A lot of times that when they do data analysis on loan approvals and the demographics inside of there, it's a reason why a lot of the demographic questions have changed with submitting loans is because of it was using unfair methodologies to make predictions as to who to approve and who not to approve. So that's just one of those big things that's out there. And so per industry, it kind of changes on who it goes to, but it's something to always just keep in mind in the back of your head to make sure that you don't fall down the rabbit hole of being biased towards one particular group or another. Scaling and optimization. So this goes back to the questions that we had during the problem definition of understanding what kind of load do we expect from our external users, especially if it's external facing. If it's internal facing, it's a little bit easier to control because you have a standard number of individuals and you can guesstimate a number of requests based off of that. But when it's externally facing, you have to keep in mind that literally anybody could come hit it, and you have to plan for that and result that way if somebody is being malicious or there's someone is trying to just extract information out of your system, that you have ways to performance and handle and secure and controls around that. So this is one of what this module does is we have a bunch of different types of methodologies that kind of come in here to allow us to say, okay, based off of the performance, this is the number of users that we expect to hit this endpoint. And this is how it works and how we can optimize for faster computation and low latency and all that. So there's a bunch of different things that come into this, but it's not necessarily kind of game changing. The nice thing about this, a lot of the cloud tools out there help do this kind of automatically, whether you're on SageMaker, Vertex AI, or what's it called? Azure AI or Azure ML. So all good places to be inside of there, but they have ways to deal with this, but it's still things you have to take in consideration and document to make sure that whoever is doing your machine learning operations or machine learning engineering knows how to set it up properly to account for those things. And then for deployment and integration, this is mostly around the aspects of making sure that whatever system that depends on a machine learning output or endpoint allows you to update that machine learning system, because there are some machine learning or AI systems that have to be updated every hour or every 3 hours or every day or 30 days. It just really depends on your case scenario and what metrics you're effectively utilizing. And putting the proper production standards and serving architecture in place is very critical to allow for those different types of things to be met. And so making sure that pieces are in place is very critical. But this is only a very small amount of what is actually truly critical. We have a series of various design patterns that go inside of the aspects of serving architecture and production standards when it comes to machine learning and AI. The nice part about this from the AI perspective, if you're on the cloud, a lot of the AI pieces follow these paradigms by default. And so it's nice to have and deploy those systems just off the bat. Mostly where you run into this is if you're deploying custom machine learning solutions that integrate with AI solutions is where you have to take this into consideration. And then lifecycle management and sustainability practices. This is just the aspect of whatever we're designing and building, is it the most efficient that it can possibly be, both from a cost perspective and from a carbon aware perspective. So one of the big things and issues that a lot of people have with machine learning is that it is very expensive from a power aspect. One of my favorite stories that recently came out was that people is starting to use ChatGPT like they used Google for very simple requests. On complex requests, it's expected, but for simple requests like what's today's weather, or how do I change a tire, or ABCDFG, whatever it is 10 times more expensive from a power consumption standpoint to use ChatGPT than it is to use Google, especially on those simple things. And so that is one of the big things out there as you design and build your own solutions. Make sure that you put the necessary guardrails and protections around it so people don't drive up your costs. And then also from a conscious economical standpoint or from an eco standpoint, make sure that they can't abuse those systems and drive up power consumption. So That being said, there's a lot of other things that come in here as well. The drift detection piece we kind of touched on with inside of the data realm. This is expected with pretty much any model, any solution that is out there, any AI solution is that you need statistical processes that control and understand the relationship of whatever you're trying to predict versus the data that you're using to effectively predict that. A lot of times those relationships can change. They can go up or down based off of various different types of things. So even if you take into account seasonality of data changing, it can still, the relationship changes. And so it's just good to have monitoring systems that go and look for that stuff so that in the event that happens, you can have an automated process. And this is where that platform, the machine learning and AI platform, is really nice. You can trigger retraining and make sure that your system is back up to date, understanding the relationship of its data that you're using to predict and the predicted value. So then feedback loops, probably one of my favorite things because it keeps people in the loop of making sure your AI models don't just run rampant and do whatever they want. Making sure that those feedback loops are kind of in there is very critical from the lifecycle management piece. You can do it without a machine learning platform, but it becomes more difficult at scale. So it's good to have kind of lessons here is having that machine learning platform will enable you to solve these complex problems more effectively, cheaply, and efficiently. So wrapping it all up. So the big thing here, and I know I just ran through the last 5 slides very, very quickly, but the big thing here is start small. That way you can get to that bigger solution at the end of the day and get to that full scale investment for what you're trying to solve. Choosing wisely, making sure that the right problem is being chosen, especially in the problem definition aspect. Can we measure it? Can we do it? Is it very clear as to what we're trying to achieve with the problem that we're trying to solve? And then build responsibly, making sure that you are collecting data and storing that data effectively, and then also building various different types of solutions without increasing technical debt. And then monitoring and improving continuously to make sure that your AI gets to that point where you have solved that complex problem. Because the biggest thing about solving complex problems and using AI inside of them, you have to iterate. To do it just straight off the bat, you will spend more time spinning your wheels doing that than if you built small and built on top of it. And then think long term. What we are building, how are we going to sustain it into the future, both from a metrics, data, power, you name it, standpoint, efficiency, governance, and adaptability. So those are all the big things to look out for. This was a very, very fast talk on how we do this. Typically, this is something that I would train with for multiple months because there's a bunch of different design patterns that have to be considered from all 10 of these various topics. But this is one of those big things that just to start off with of thinking about how we're going to design machine learning systems and AI systems to solve complex problems. And yeah, that being said, questions. And if you don't want to ask questions, please contact me. That's my LinkedIn QR code, so you can connect with me, or you can send me emails. So that's my email there too. So
Thank you, Scott. That's great. I love what you're saying about start small. I think we talk a great deal and you have a background in physics about these are scientific experiments, and if you have a whole bunch of variables and you never really know what's causing issues or what's giving you the right answers. So start small, build on it, and move on to the next. So thank you so much for the talk today.
definitely.
All right. And thank you all for joining us next week. Join us for Humans, Agents, Time, and Tools with Kevin Jordan to explore the evolving partnership between humans and intelligent agents. And we will see you all next week. Thank you so much for being here.